try this again. All right. So how we do that, okay? The first thing is if we're looking at n of x divided by d of x, and we want to make them into partial fractions. If the degree of n of x is greater than or equal to the degree of d of x, we will divide the denominator into the numerator to obtain our polynomial plus n1 of x, which is our remainder, over d of x, right? So this is my remainder. So this is like doing our long division. Okay, do you guys remember doing the long division? Okay. All right, so one of my partial fractions would be whatever the dividing is plus the remainder of the two. Okay. All right, factor. We always want to make sure we factor the denominator. Okay, so we will completely factor the denominator into factors of the form p times x plus q to the n power and ax squared plus bx plus c to the n power. Okay, so we're going to factor those, where, I can't even spell, ax squared plus bx plus c is reducible. Reducible, okay? So first thing, we always want to factor our denominators, okay? So that we can find if we can break it into those partial parts, okay? Which that's actually the first one, which we'll do in that sense, okay? Linear factors. So if we have linear factors, for each factor in the form of p of x plus q to the n power, okay? The partial fraction decomposition must include the following sum of m of fractions, okay? So if it's linear, it's just going to be a over p of x plus q, okay? Plus, so that's a sub 1, a sub 2 over p of x plus q. So say we have another one, okay? Plus, and we go all the way to a of m to p of x plus q to the n power, okay? So if we have, like, say we factor the denominator and we have three parts of it, three binomials, we're going to have three fractions here that we add, okay? If we have 4 or 5, we will have 5 fractions here. So this is just taking it out to how many fractions we actually have, or how many binomials in the bottom, okay? Now, if we go and we have quadratic factors, so now our denominator has an x squared, not just an x, not just linear. We have quadratics, okay? So we're in the form of ax squared plus bx plus c to the n power, okay? The partial fraction decomposition now is, instead of just a, it's b, we use b instead, bx plus c of 1, okay? Over whatever that quadratic factor is. Okay, so whatever that quadratic factor is. Plus, so say we have another denominator that's a quadratic. We would then use b of x plus c over the same thing. Okay, now this kind of seems a little confusing all the way out to our last one. Okay, seems really confusing, but once you get the hang of it, it's going to be a little easier for you, I promise. Okay. So what we're going to do is, in example 1, we're looking at that first one that I had up here. Okay, we're going to write the partial. So the first thing we always want to do right now, if you notice, my degree in the numerator, you can't see that, is less than the degree in the denominator. So we're not going to divide these. So the first thing we're going to do is we're going to factor that denominator. Okay, so go ahead and factor that denominator for me. So I'll give you a chance to go ahead and factor that. And when you factored, what did you guys get?
X plus 2, X minus 3.
Got X plus 2 and X minus 3. Perfect. Okay. Is everyone okay with that? Now, we know to get this, this is my common denominator, right? Okay. And since that's a common denominator, okay, we know that these are linear factors, right? So if these are linear factors, we're going to break it up into the partial fractions, okay? And my partial fraction is going to have each one of these, since we have two binomials, we're going to have two partial fractions, one with x plus 2 and one with x plus 3, okay? Are you guys okay with that? Because to get to this, I'd have to have my common denominator, which would be x plus 2 times x plus 3, right? Okay. Now, because these are linear, okay, these are linear here, we just have linear factors of a plus b. Okay, so a number over x plus 2 plus b over a number x plus 3, or x minus 3. I'm sorry, I put plus. Let's do minus. Okay, is everyone okay with that so far? Okay, now we know if I look at this problem, okay, to get to the x plus 7, I know I would have to technically multiply a times what?
X
Minus 3. So I have to take a times x minus 3. And I'd have to take b times what?
X plus 2.
X plus 2. Right? Are you guys okay with that?
Mm-hmm.
And that should get us, if I add these together, that should equal my numerator, correct? Because if we have common denominators, you could add the numerators and to get to the numerator, right? So that would equal our x plus 7. Okay, are you guys okay with that? Now, from this, okay, we need to know what a and b are to get to these actual partial fractions, okay? Now, to be able to find my a and b here, let's think about this. We know, since these are linear, x can't equal what two values, or what are my solutions for x? X could equal a positive 3, or x could equal what?
Negative 2.
Negative 2, right? Why? Because if I set each one of these factors equal to 0, that's what x would be, right?
Mm-hmm.
So then could I plug each one of these x in and solve for a or b?
Yes. Yes.
Yeah. So let's go ahead. Which one do you guys want to plug in first? Your choice.
3.
3? Okay. So we're saying x is 3. So I'm going to go ahead and plug 3 in for x. So 3 plus 7 equals a times 3 minus 3 plus b times 3 plus 2. Okay. What's 3 plus 7?
10.
10.
3 minus 3?
0.
And what's 0 times a?
0.
0. So a is gone, doesn't it? A
Mhm.
cancels out. Plus b times what's 3 plus 2?
5.
5.
5. So we have 5b. So now can we solve for b?
Yes.
Yeah. So b would equal
2.
2. So now I know what b is. Can I find a?
Yes.
Yeah, because now we could plug in what other value?
Negative 2.
Negative 2. So now let's go ahead and plug in negative 2. So negative 2 plus 7 equals a times negative 2 minus 3 plus b times negative 2 plus 2. Okay. What's negative 2 plus 7?
5.
5.
5.
Negative 2 minus 3 times a
Negative
would
5.
be negative 5a.
Negative 5a.
And what happens to these b's?
They cancel.
They cancel out. So what would my a equal?
Negative 1.
Negative 1. Okay. So now in my partial fraction, I needed to know what a was and what b was, correct?
Yes.
Well, do I know what a and b is?
Yes.
Yeah. So my partial fraction would be negative 1 over x plus 2 plus what's my b?
2.
2 over x minus 3. So now if I would go to add these up, actually find my common denominator, I would end up with what? X plus
The
7
starting.
over x squared minus x minus 6. And there you go. Okay. Any questions with that one?
No.
Okay. All right. Next one here. Example 2. What do you notice about the numerator and my denominator?
Very long.
It is very, very long. Yes. What else? What's the first thing we should look for?
Common factors. Or
Okay.
like
We
terms,
always
whatever.
want to see if the degree is greater than the degree of the denominator. Okay.
Yeah, divide. Yeah.
Right. And in this case, is my degree of my numerator greater than the degree of my denominator? Yes, it is.
Yes.
Whereas the first one was not. That's why we moved on to the next one where we factored. Okay. So since this satisfies this, we're going to do long division. Okay. So we're going to start with long division. And do we know how to do long division with polynomials?
Yes.
Yes, we do. Okay.
Mhm.
So x to the 4th plus 2x cubed plus 6x squared plus 20x plus 6. And we're dividing it by x cubed plus 2x squared plus x, right? I really gave me no room, but that's all right. All right, so let's go ahead and first. X cubed goes into x to the 4th how many times?
One.
So what's 1? So it's just x, right?
Mhm.
So now I'm going to take this x and multiply by everything here, right? So x
Yes.
times x cubed is x to the 4th. X times 2x squared would be 2x cubed.
2x cubed.
X times x is
X squared.
x squared. And then we subtract these, right?
Mhm.
X to the 4th minus x to the 4th is?
Cancel.
Cancel. 2x cubed minus 2x cubed.
Cancel.
6x squared minus 1x squared.
5x squared.
And then bring down the plus 20x plus 6. Now, can x cubed go into 5x squared?
No.
No. So this here is my remainder. You guys okay with that?
Mhm.
Okay. So right now, when I divide this, this actually equals x plus 5x squared plus 20x plus 6 divided by x cubed plus 2x squared plus x. Are you guys okay with that?
Yes.
Okay, now do you guys see how my numerator's exponent is now less than my denominator's exponent?
Yes.
Yes, so that's what we want. So with that, we're going to write the partial fraction from this. Okay, so the first thing now, once we get that, we need to factor our denominator. Okay, so go ahead and factor that denominator. You guys get x times x plus 1 squared.
Mhm.
Is that what you guys got? Okay. If not, let me know. Okay. So now, if you look at this to write our partial fraction, okay? So let's look at to write our partial fraction. The nice thing is the x, that is part of my final answer because that went in evenly. This is the part where we're breaking it off, okay? So now when we go to do that, we have different parts. We have a denominator of, remember we always did it of each part for my common denominator. So we have an x, we have an x plus 1, And then we also have an x plus 1 squared. We want to make sure we write out every single part that we can in that sense. Okay? So now, with this is just, these are all linear still, aren't they?
Mm-hmm.
And since these are all linear, we can just do x or a, b, and c. So we need to find a, b, and c in this sense. Okay? Now, with this a, b, and c, it's coming from this green part, my remainder part. Okay? So remember, how do we get that remaining part? Okay? We always take each one of these numerators, right? Multiply it by its common denominator and set it equal to that numerator because that's where we want to get to, right? So let's think of a for a second. A would have to be multiplied by what to get my common denominator here? What would a have to be multiplied by to get that common denominator?
X plus 1
X plus 1
squared.
squared, right? Because there's two x plus 1s. You guys okay with that? B, what would b have to be multiplied by?
X.
X and
X plus 1.
plus 1, right? Because it only has 1 and we need 2 of them. Plus c, and what does c have to be multiplied by?
X.
Just x. And then that is going to equal our 5x squared plus 20x plus 6. Okay, are you guys okay with that?
Mhm.
Okay, now we can go from here because these are all my common denominators. I can tell me what x could equal, right? What are my choices for x? X could equal 0.
-1.
X could equal -1, right? You guys okay with that?
Yeah.
Now, can we plug those values in?
Mm-hmm.
Yeah, let's go ahead and start plugging those values in. Do you guys want to plug in 0 or -1 first?
0.
0. Okay. So 5 times 0 squared plus 20 times 0 plus 6. What do you guys get real quick? Let's do that side, make it easy.
6.
That's 6. All right. All right, sorry, I kind of got sidetracked. All right, so then a times 0 plus 1 squared plus b times 0 plus 1 plus c times 0. What's 0 plus 1?
1.
Squared
1.
times a.
A.
What's 0 times b
0.
times 1?
0.
0, so my b cancels. And what's c times 0?
Cancel.
Cancel. So my a is 6. Okay, you guys okay with that?
Mm-hmm.
All right, now we got to try -1. All right, so using the same thing, I'm going to go ahead and come up here if you guys don't mind. So 5 times -1 squared plus 20 times -1 plus 6 equals. Let's go ahead and do that side. What's -1 squared?
1.
1 times 5.
5.
20 times -1
-20.
plus 6. All right, so what's 5 plus 6?
11.
11. And 11 minus 20?
-9.
So we get -9 equals. Okay. All right, now we're still a times -1 plus 1 squared plus b times -1 times -1 plus 1 plus c times -1, right? What's -1 plus 1?
0.
0 times anything?
0.
So a cancels. -1 plus 1?
0.
0 times anything?
0.
So
Cancel.
b cancels. And then what's c times -1?
-1.
-C.
negative C, negative 1C. So C would equal
9.
9. Negative 9.
positive 9. Right? So
Oh,
now
yeah.
we have A, we have C, but we're missing what?
B.
B.
B, right? We don't know what B is at all, right? We have no clue at all, but we do know what A and C are. So I could plug A and C in there for that, right?
Yes.
And
Mhm.
thinking about graphs, I can pick any value for X and be able to solve for a letter, couldn't I?
Yeah.
So does it really matter what value I pick for X to be able to solve for B if I know what A and C both are?
No.
No. So your choice, it doesn't matter which one. Give me a number for A. Give me an easy number for X, I mean.
2.
1 or 0.
We can't do 0. Why can't we do 0? We already did 0,
2.
Oh,
right? I'm going to choose 1 because I like
Oof.
multiplying by 1 better than 2s, to be honest. So let's just choose X equals 1. Doesn't matter, okay? And let's plug it in. Let's plug everything we know. So 5 times 1 squared plus 20 times 1 plus 6 equals, what's my A?
6.
6 times 1 plus 1 squared plus, do we know what B is?
No.
No, so we'll leave B times X, which is 1, times X plus 1, so 1 plus 1, plus what's my C?
9.
9 times 1. My X is 1. So now the only letter we have in there is B, don't we?
Mhm.
So now we can keep solving. So what's 1 squared?
1.
1's 5.
5.
20 times 1?
20.
All right, so what's 5 times 6, or 5 plus 6?
11.
11 plus 20,
31.
31 equals. All right, now we got to do parentheses and then the exponent. 1 plus 1 is
2.
2. 2 squared,
4.
4 times 6.
4.
24.
24.
24.
Plus 1 plus 1,
2.
2 times 1
2.
times B,
2B.
and 1 times 9.
9.
24 plus 9,
33.
33, plus 2B equals 31. How do I move 33 over?
Subtract it.
Subtract, so I get negative 2 equals 2B. So B would equal
Negative 1.
negative 1. So now, do I have A?
Yes.
Do I have B?
Yes.
Do I have C?
Yes.
Yes, so now I can actually write my partial fraction. So we cannot forget the original X, right? Because that's what we divided by. So X plus, now what was my A?
6.
6 over X plus, what's my B?
Negative 1.
Negative 1 over X plus 1. And would it be okay if I put minus 1?
Yeah.
Yeah, that's fine. I just have plus negative for some reason. Plus, what's my C?
9.
9 over X plus 1 squared. And this would be, if I go to actually add this up, I would get back to that original problem up there. Okay. We cannot forget this because that was the first thing we divided. This, the rest of it comes from my remainder. Okay. That's the original division. The rest comes from my remainder. Okay. That's the reason why we have to do the X plus 1 twice too. Okay.
That was a lot of steps.
A lot of steps. But it's not, that's why I said it's not that hard. It's just the matter of where do I go from there? What's the next thing? Where do I start?
This is Cochran.
Yes, ma'am.
Real quick, I'm just confused. Back at the pink portion, how
Yep.
did you like figure out what you needed to multiply by to
Okay.
do the things?
Get to the orange.
Yeah.
Okay. Excuse me. So like from here, we know my common or my denominator is X and X plus 1 squared, right?
Mm-hmm.
So we had to list each one of those. So X, the X plus 1 has to be written once, and then the X plus 1 squared has to be written. Okay.
Okay.
So now we look at what is my common denominator. my common denominator is this x times x plus 1 squared, right?
Okay.
So if I'm looking at, if I just have my x here, what am I missing from that? The x
Okay.
plus 1 squared. That's why it's a times x plus 1 squared.
Okay.
Okay. Then for the b, I have an x plus 1, but I'm missing the x, and I'm missing one more of the x plus 1 because there's supposed to be 2 of them.
Okay.
Okay. And then the x plus 1 squared for the c part, I have the x plus 1 squared. I'm missing the x. That's why I just multiplied c by x.
Okay. Thank you.
You're welcome. Okay. Any other questions before we go on? All right. The next one here. Okay. So the first thing we look, is my numerator degree greater than the denominator's degree?
No.
No. So we can't do long division. So now the first thing we do, since we can't do long division, we factor that denominator. So go ahead and factor my denominator. And what do we get when we factor that denominator? So what did you guys get when you factored? So we had a GCF of x, and we're left with x squared plus 4, right? Can I factor x squared plus 4 farther?
Yes.
I can. To what, JD?
Oh, wait. No.
No, it's a plus sign, not a minus sign. So those aren't
Yeah.
different of 2 squares, are they?
No.
No. So this is as far as I can factor it. So we know in this sense that this can only be broken down to a fraction of x and x squared plus 4, right?
Yes.
You guys okay with that? Okay. Now, in this sense, if I look at it, x is linear, right?
Yeah.
So that is just a over x. Okay. Now, when I look at the part for b, this one's quadratic. And why is this one quadratic?
Squared.
Because it's x squared, right? The only way I could solve that is subtract the 4 and then take the square root, right? This is quadratic in this. So we have to write a linear system above it, linear function. So we're going to have bx plus c. So we're going to have a binomial over top of a, technically a trinomial, a quadratic. So linear over quadratic, okay? And we always put the first one with that x, okay? Does that make sense to you guys?
Yes.
Okay. So now we're going to do the exact same thing as we did before, okay? So we're going to keep the numerator, which is that 3x squared plus 4x plus 4. And then we're going to look at the numerator here. We're going to take a and multiply it by what? What would be the common denominator? So we already have the x. We just need the x squared,
X squared
plus
plus
4. Good. Then plus, now we have bx, right? We have this bx plus c, and we need to multiply that by what? What's
X.
just the x. Okay. Are you guys okay with that? Now, if you notice, we have lots of different things going on. And because of the x squared, we can't just set them equal to 0. Okay. So what I'm going to do is I'm going to go ahead and just distribute this out to get rid of those parentheses. Okay. What's a times x squared?
AX squared.
X squared. What's a times 4?
4A.
4a. And then bx times x is
BX squared.
BX.
x squared, yeah. And then c times x is,
CX.
CX.
okay? You guys okay with that?
Mhm.
Now, what do you guys notice about these over here? Do you notice how like ax squared and bx squared, I could technically add those together? They're like terms technically, aren't they? Because a
Yes.
and b are supposed to be numbers. So could I
Yes.
write that as a plus b times x squared?
Yes.
You guys okay with that? Does that make a little bit of sense there?
Mhm.
Okay. And we know this all equals 3x squared plus 4x plus 4. Okay. You guys okay with that? Now I'm going to go ahead and I'm going to rearrange this again and put it in standard form. Okay. And what's standard form again? The highest exponent to the
Lowest.
lowest. Because remember, A's and B's are technically, A, B's, and C's are all numbers, aren't they?
Mhm.
Okay. All right. So we know this side has to equal this side, doesn't it?
Yes.
Don't they look pretty close, the same?
Yeah.
Yeah. What do you notice about CX is supposed to be the same as what?
4X.
4X. So if CX is supposed to equal 4X, what would C equal?
4.
4.
And A would equal 1.
And A would equal 1. Why?
Because 4
4
times 1 is 4.
equals 4A. So A would equal 1. So guess what? You know what C is. You know what A is. Do you think we can find what B is?
Yeah.
Yeah, because
2.
oh, yeah, hold on. Yeah, but yeah, it is. But we know that this 3x
Easy.
squared should equal this A plus B times x squared, right?
Mm-hmm.
Well, what happens to these x squareds when you divide them?
They cancel.
They cancel out.
Cancel.
So we get 3 equals A plus B. But what is A?
1.
1. So B would equal
2.
2. So now do we actually know what A, B, and C are?
Yes.
Yeah. And if we know what A, B, and C are, could we write our partial fraction?
Yep.
Yep. So coming back up here. A, what's my A?
A is 1.
1. So 1 over x plus, what's my B?
2.
So 2x plus, what's my C?
4.
4 over x squared plus 4. And there you go. So I kind of like, honestly, when it's a quadratic on the bottom. I think it's a little bit easier because you don't have to plug anything in. You're just looking at, they match up to both sides, don't they?
Yep.
Mhm.
All right. Let's look at example 4. So again, first thing, is my numerator degree greater than my denominator degree?
No.
No, it's not. Because remember, x squared plus 2 squared, doesn't that mean x squared plus 2 times x squared plus 2? And
Yes.
when you guys then go and FOIL it, don't you get x to the 4th?
Mm-hmm.
Mhm.
So this denominator is actually x to the 4th plus 4x squared plus 4. They just factored it for you. So my numerator degree, and you can't see that very well, sorry. My numerator degree is not greater than my denominator degree, is it?
No.
No. So we won't divide this. Okay. So we can go ahead and the nice thing again, it's already factored for us. So we can set up our partial fraction. Now, we know my denominator is going to be this x squared plus 2 once, and then it has to be the x squared plus 2 squared, wouldn't it?
Yes.
We always have to list it twice, okay? Those parts if it's raised to that exponent. Now, our denominators are quadratic. So what will my numerators be?
bx plus c.
Right, so it would be our linear, right? And we need different letters. So I'm going to always start with A. So I'm going to have AX plus B. And you can use any letters. It really doesn't matter. I just tend to go in order. So I have AX plus B. So then the second side would be CX plus D. We just need to make sure we have a linear function up there. That's all. Okay. If you want to use different ones, it doesn't matter. Okay. All right. Any questions with that so far? All right, so now we know the top has to equal 8x cubed. And I'm going to go ahead and put in missing variables for us. So would it be okay if I wrote this as 0x squared plus 13x plus 0? Is it okay if I write it that way just because we have x squared and we didn't have x squared in my numerator?
Yes.
Equal. Now, we're going to take this ax plus b, and we need to multiply by its common denominator, right? We already have x squared plus 2 once, but we actually need it how many times?
Twice.
Right? So I need to again multiply by x squared plus 2. You okay with that? Plus that cx plus d. Do I need to multiply by everything? Anything?
No.
No, because my denominator is that x squared plus 2 squared, and that's already in that denominator. So it's already got the common denominator. Okay. So now what I'm going to do is when I have ax plus b times x squared plus 2, can't I just FOIL that out?
Yeah.
Yeah, let's go ahead and FOIL that out. So ax times x squared would be ax cubed. Ax times 2 would be 2ax. B times x squared would be bx squared. 2 times b would be 2b plus cx plus d. Okay. You guys okay with that? Is there anything that are like terms in the green? Is there anything that are like
No.
terms in green? What about 2ax and cx? Would those be like terms? Because remember, you always want to think A and C are numbers, not letters. So 2 times a number, x, and a number times x. Aren't those like terms?
Yes.
Yes. Okay. Now, and isn't 2b and d like terms also? Yes. So I'm going to go in standard form, ax cubed plus bx squared. Now would be the 2ax and the cx. So could I factor out the x and write it as 2a plus c times
Yes.
x?
Yeah.
And then I have plus 2b plus d as my constant, right? You guys okay with it? So now we have our cube term, our square term, our linear, and then our constant. And we have that set equal to ax cubed plus 0x squared plus 13x plus 0. Now, do they look alike for you? I think so. Doesn't ax cubed and 8ax cubed the same? Yeah. So isn't 8x cubed equal to ax cubed?
Yes.
So what would a equal?
8.
8.
A would equal 8. Okay. Hey, we have 0x squared. Isn't that the same as bx squared? So 0x squared equals bx squared. So what would b equal?
0.
0. You guys okay with that so far?
Yeah.
Okay. And then we have 13x. Doesn't 13x equal this 2a plus c times x? And what do you guys know?
A and B.
A and B, right? So what happens to these x's?
They cancel.
They cancel. So I have 13 equals 2 times, what's my a?
A is
8.
8.
8. Can I solve for c now?
Yes.
What's 2 times 8?
16.
16. And then move the 16 over, so c would equal
-3.
-3, yeah. Okay. And we have a 0 is my constant equals 2b plus d. And what do we know about b?
It's 0.
So d is going to equal 0, won't it? So now do we know what a, b, c, and d are?
Yeah.
When we write our partial fraction.
Yeah.
Yeah. So ax plus b. So what's my a?
8.
So 8x plus, what's my b?
0.
0. So do I need to have the plus 0?
No.
No. So I'll have x squared plus 2 plus, what's my c?
-3.
3.
Yeah,
so
negative
-3x plus d, but my d is 0. So do I need that?
No.
Nope. And then we have x squared plus 2 squared. And again, you could have minus instead of plus and negative. And there you go. Okay. All right. Any questions with that so far?
No.
No. All right. One last one. So do you see how this is like, it's not super hard. It's just keeping track of everything.
Mm-hmm.
Yeah. All right. All right. So let's look at this one here. Is my numerator's degree greater than my denominator's degree?
No.
So we're good in that sense. So then we would try to factor, but isn't this already factored?
Yes.
Yes. So we can go ahead and write our partial. Now remember my denominator, since I have that x squared there, I would have to do x, and then I'd also have to do x squared, right?
Right.
All right. Now we look at this, yes, this is x squared, but if I put that in parentheses, that's still technically linear, right?
Mm-hmm.
Okay, so this would just be a and b here, okay? Because we're looking at it as x times x. So they're linear in a sense of individualized, okay? Now we have this x squared plus 1, okay? So we're going to have that x squared plus 1. And then we're going to have it as x squared plus 1 squared, correct? So now as I look at this, because it's a quadratic function of x squared plus 1, we will have cx plus d, and we'll have like ex plus f. Okay, so lots of letters here, right? All right, so now we have to look at what do I need to multiply each of these by, right? So let's kind of look at this. I'm going to take my numerator, which is x plus 5. All right, but we're going to take a, and I only have one x, right? But I need to have x squared, so I need to multiply that by x.
X.
And I also need to have the x squared plus 1 squared. So I need to multiply by x squared plus 1 squared, right? My b has the x squared, which is great, but I don't have the x squared plus 1 squared, do I?
No.
So I need to multiply by the x squared plus 1 squared. Okay. Plus, all right, the cx plus d, I only have the x squared plus 1, but I need it how many times?
One more.
So I need to multiply by x plus 1 one more time. Plus, I'm also missing the x squared from the beginning, right?
Mm-hmm.
plus we have this EX plus F. The nice thing is I already have the X squared plus 1 squared, but I'm missing the X squared of it all. All right, you guys okay with all that? Now, can we go ahead and multiply all of that craziness out?
We could.
We
Mhm.
could. Yeah, we could. All right, so I'm going to start with the end here because I think the end's easier because we would just distribute the X squared, right?
Mhm.
Would that be X squared? And wouldn't that be EX cubed?
Yes.
Now, when I go to multiply X squared times X squared plus 1, isn't that X to the 4th plus X squared?
Yeah.
Yep. And then I need to multiply by CX plus D. So wouldn't I have to FOIL that out?
Mhm.
Whew, it's going to be a lot, isn't it?
Yeah.
So we're going to have CX to the 5th plus CX cubed plus DX to the 4th plus DX squared. You guys okay with that?
Mhm.
Okay. Phew, that seems like a lot though. All right, let's keep going. X squared plus 1 squared. So isn't that X to the 4th plus 2X squared plus 1
Mhm.
times B? So now I'm going to distribute the B to everything, right? So I have plus
Yes.
B plus 2BX squared and then plus BX to the 4th. You guys okay with that?
Mhm.
All right. And then the first one here. We know X squared plus 1 squared is X to the 4th plus 2X squared plus 1 times X times A. And then when I distribute AX to the 4th to everything, wouldn't I get AX to the 5th plus 2AX squared X
Yes.
cubed, sorry, right?
Mhm.
Plus AX. So that was a lot of, and it's really crooked, sorry. All right, so let's kind of find some like terms here for you. Let's see, X to the 5th. Do I see anything that's equal to X to the 5th?
A and C.
C X to the 5th, yep. So isn't that the same thing as A plus C to the X to the 5th?
Yes.
Okay, we're good with that. All right, let's go. The next one would be, if this is 5, the next one would be 4s, wouldn't it? So I'm going to cross those out.
Mhm.
Let's do 4. So we have BX to the 4th. We also have DX to the 4th. Are you guys okay with that?
Yeah.
Okay. So we have plus B plus DX to the 4th. We're done with those. Okay. Then we have cubes would be next. We have cube here. We have a cube here. And we have a cube here. So wouldn't that be 2A plus C plus E times X cubed? I think so. Okay. Then we have squareds. 2bx squared and dx squared and fx squared. So that would be 2b plus d plus f times x squared. Excuse me. All right, and then we have ax and we have a b. I think that's it, everything, right? Equals x plus 5. Is everyone okay with where I was at on that?
Mhm.
Okay. All right, now, normally, because we have x to the 5th, 4x, x cubes, x squared, I'd put 0x to the 5th. 0x to the fourth, but I kind of ran out of room. Okay. But if we notice here, the only thing that has single letters is my constant and my AX, right? And do I have a constant and an X on the left-hand side?
Yes.
Yeah, so could I say AX equals X?
Mhm.
So what does A equal?
1.
1. So I know what A is. And then it says 5 is my constant. 5 would equal B. So right off the bat, I know what A and B are. Now, do I see any quantities that just have A or B with one other letter?
Mm,
I do. Don't I see
Yeah.
this A plus C?
Yeah.
I have this A plus C times X to the fifth. What is that going to equal? Do I have an X to the fifth to the left-hand side? No, so wouldn't that be 0x to the fifth?
yes.
Yeah, so what happens to these X to the fifths?
They cancel.
Cancel.
Cancel out. So then I have A plus C equals 0. And what does A equal?
A equals 1.
1. So 1 plus C equals 0. So what does C equal?
-1.
-1. So now we know what A, we know what B is, and we know what C is. Now let's look at, do you guys see how you have B plus D times X to the fourth?
Mhm.
Don't we know what B is?
Yeah.
Yeah. And what do we have, excuse me, X to the fourth to the left-hand side?
No.
No, so wouldn't that be 0x to the fourth?
Yes.
So then we have B plus D equals 0. And what does B equal?
5.
5. So what does D equal?
-5.
-5.
-5. So now we know what A, B, C, and D is. Now we just need to know E and
F.
F. Well, we know here's E and here's F. And if you look, X cubes, again, there's no X cubes, no X squared. So we're just going to set these all equal to what? 0, won't
0.
we?
Mm-hmm.
So we have 2 times A. What's my
Mhm.
A? 1.
1.
1.
Plus C, which is -1, plus E equals 0. And I skipped the X squareds because we know they're going to be 0. 2 times 1?
2.
2. 2 minus 1?
1.
1. Plus E equals 0. So E equals
-1.
-1. All right, and now let's do the F. 2 times B. What's my B? 5. Plus my D, which is -5. Plus F equals 0 again, right? Oh, you guys can't see, sorry. So then 2 times 5 is 10. 10 minus 5 is 5. Plus F equals 0. So F equals -5. So now, do we have all the letters we need?
Yes.
Yeah, so let's write our partial fraction. Let me zoom out. Okay, so going from the purple there. So A over X. What's my A?
1.
1. So 1 over X. Plus B over X squared. What's my B?
5.
5. So 5 over X squared. Plus, what's my C? X.
-1.
-1 X. What's my D?
-5.
-5.
-5 minus 5 over, and I'm going to clean it up here in a second. X squared plus 1. Plus, what's my E?
-1.
-1 X. Plus, what's my F?
Negative.
-5
-5.
equals
Negative.
X squared plus 1 squared. So there's my partial fraction, but I'm going to clean it up because I don't like all those negatives. So I'm going to have 1 over X plus 5 over X squared. I'm going to change this minus, and if I change that plus to a minus, these change to become positives. And then same thing here. I'm going to change this plus to a minus, and this will change up top. There you go. Those are your partial fractions. So if I go to actually add or subtract all of these, I would get back to this original problem. Whew. That's it. It was a lot, but we did it.
Mm-hmm.
All right. Any questions with that all? So as I said, I don't think it's super hard. I just think it's a lot of work and figuring out where do you go with first? What do you start with?